So here we're installing the insulation onto the concrete deck. We've installed the Polera vapor barrier, and now we're fully adhering the ISO insulation board to the Polera, which is fully adhered to the concrete deck. So that's how we put down the insulation board, and then he'll stand on that. That cools fairly quickly. And then on top of that, we put our wood fibered separation board. Okay, so here we have the guys putting on the wood fibered insulation on top of the ISO. That's a separation between our actual roof system and the insulation layers. But you don't have to actually put ISO on top of a concrete deck. You can go the traditional way that was done a long time ago and just go with 1-inch wood fibered insulation. The only reason you put the ISO if you'd like an R rating on top of your concrete deck. But traditionally, years and years ago, back when I started, ISO was never used. It was always just a 1-inch wood fiber board over top of the concrete. And even a lot of times, we just put the roof system, we tarred the actual roof system right to the concrete deck. That's what you find a lot of these apartment buildings. You go to take the roof off, there really isn't even any insulation. That's the way they used to do it. Now, people are realizing the importance of insulation, so we put in, you can go a thickness of ISO, which with whatever R rating you're looking to achieve, you can use it in the thickness of insulation that you put down. But so this roof called for 1.5 inches of ISO insulation and then a 1/2-inch wood fiber board on top of that. So now we're putting that down, and then let's take a look at the guys installing the roof system on top of the insulation. As you can see here, this is at a drain where the water drains to, and this is called a cross sump. You can actually see, let's name that because it's the shape of a cross, and what that does is these arms of the cross are dropped down lower. So the 1.5-inch insulation's here, while we drop it down to a 1/2 inch in the cross. What that does is it pulls the water to the drains. The water wants to drop down to a lower area. Well, the lower area is at the drain. So we make the drains the lowest, the water starts pulling, and when water starts moving, it's like a river, it wants to keep moving. So it helps with drainage of our roof. So anytime we have a drain, we sump it. We either square sump, cross sump, we can do line sumping. Whatever way we want to stretch those arms out to grab the water to pull it to the drains, we can do so. In this drain situation, it's called cross sumping. You can see it is the shape of a cross. So here's one of our teams installing the polyester reinforcement material on top of the insulation. The first layer of hot asphalt is put right on the insulation. The polyester is then rolled into it. Then there's a second layer of hot asphalt and another layer of polyester is rolled into that. Then there's the top flood coat, which takes away the seams across the entire roof system. So here is another one of our teams putting on the second ply of polyester. As you can see right here, the first ply has been installed. Now we're adding another layer of hot asphalt and a second layer of polyester reinforcement. After this, we'll show you the flood coat, which takes away the seams. So here you can see one of the teams flood coating the roof. They pour hot asphalt on top of the polyester, extremely thick, and I'll explain to you why we put it on so thick in the next segment. But as you can see, we pour the hot asphalt out of the buckets and then we mop it around to move it around the roof system. What that does is it gets absorbed by the polyester, encapsulates everything, and now the polyester is a one-piece roof system without any seams. It takes away the seams, but I'll go on to explain that now. So what you can see here is the final flood coat after it's cooled down. As I showed you before, you could see the men pouring out the hot asphalt. Well, this is when it cools down. It becomes a very tough roof system, yet very flexible. It's what you need for life longevity of a flat roof. After this, we apply a sunscreen because the asphalt needs a sunscreen so the sun doesn't attack it and break it down. So you either have the traditional gravel that's been around for 150 years, made with all tar and gravel roof systems. It's called a pea gravel. You also have our bright white marble option for high reflectivity, and you also have the Duroc TO coat, white elastomeric coating that we can put on your Toughroof, and that's even higher reflectivity rating than the marble. So, but talking about this flood coat, the reason why we pour such a thick flood coat is what it does. Two things. The polyester absorbs the hot asphalt. So what it's doing, it's one of the only materials out there that actually truly absorbs asphalt. It completely absorbs the asphalt and it becomes one with the asphalt. That's what makes the asphalt so incredibly tough. That's why we call it a Toughroof. But what it does when you pour that flood coat on nice and thick is it actually takes away all the seams in the polyester too. That's why we call it a hot asphalt seamless roof system. What that does is no matter how big your flat roof is, from small roofs to flat roofs as far as the eye can see, when we're finished the roof system on that flat roof, it's a one-piece roof system, one-piece membrane over the entire roof without any seams. If you eliminate the seams, you eliminate Mother Nature trying to attack those seams, be it ice backup, high volumes of water. They all want, if it's a seamless system, that's where they attack the system. They try to get under those seams. Torch-on systems, single-ply systems, they all have seams, where ours don't. They get buried in the flood coat of hot asphalt. So Mother Nature has a really hard time getting through our roofs because they don't have seams. That's the whole premise behind the roof. So let's take a look at putting on some sunscreen on top of this flood coat. So just before we put the gravel on, we address the penetrations. So let's take a look at the penetrations in the roof, which are pipes or drains or anything like that. So this happens to be your regular copper 3-inch plumbing exhaust pipe that comes up through the concrete deck. This is the pipe. What we do is we take the field 2 plies up to the pipe, and then we have a thing called a high dome, which is made out of aluminum. It goes over the pipe, and then it gets hot asphalt to the roof. Then we cut polyester material into like the shape of a donut. We actually call them donuts, 2 of them, one small one, one large one, and we put them around the pipe. And what that does, it makes the pipe watertight, but what it also does, because you're adding more asphalt around the pipe area, it tends to make the water go away from the pipes because the pipe area is higher. So that's another reason why we do it. Then we take a cold mastic, we put it around the bottom, put it around the top. It makes our penetrations extremely watertight. The actual penetration areas can outlast the surrounding roof around it. The reason being is that the penetrations generally are where you can get leakage. So if you address them thoroughly, then they will outlast the roof system around them, and you don't have to worry about the leakage at the penetrations. So let's take a look at the drain now. So here is that cross-sumped drain area I was showing you earlier when we were insulating. So you can see the actual part where it drops down here. So what this is this is the higher insulation. This is the lower insulation. And here is the drain right here. So what happens is all the water from the higher area now runs into the drain area and falls down the drain. So that's how we do drains. We sump them down into a lower area. We put 2 plies in the lower area. Then we put the drain in with hot asphalt down onto that field. And then we put donuts, just like we do the high domes there. We put donuts, 2 donuts around each drain to make it very watertight. But now we've sumped the drain, which means making it lower. This is the cross. Right here, this is a cross sump, so now the water wants to come into these arms and then drop into the drain. It helps a lot with pulling the water from the outer areas to the drain area.